Hi, I'm Tonis. I'm an engineer here at Docker, Docker engine maintainer, Moby Core maintainer. And I'm here to tell you about and give you a preview of a new project we have called Buildkit. So let's start with the definition. So Buildkit is a low-level toolkit for building software using containers. So you can think of it as a fresh take of the same problems that Docker Build at the moment is solving. It's a completely open source project, development happening in open, all written in Go, of course. And the development happens under the Moby organization. So the Moby project was something we introduced back in DockerCon to introduce this framework of components where you can take a set of components and assemble something like Docker. And Buildkit is one of the examples of such a component. So this will be a component that hopefully will be the upstream of Docker build feature in the future. And another one I wanted to mention is a containerd project. So this is a new project developing a container runtime that will be used in Docker. It will be used in Kubernetes. Buildkit also uses this project heavily. It relies on it for everything, for container execution, pulling images, everything it does with storage is managed by this project. And you can also integrate Buildkit with containerd when you're running it, so that when you build this and something like an image, you see it in containerd, you can start using it, you can push it and do things like that. So let's quickly cover why Buildkit is better than what you might be using at the moment with Docker build and with Docker files. So first one is improvements around performance. Performance, of course, is very important for a build tool. You don't want to watch while your code is compiling. So in the moment when you're using a Docker file, every command runs after each other. Every command needs to finish before the next one starts. No way around that, even if you use multi-stage builds and cool stuff like that. This is now history. In Buildkit, we have a new fully concurrent solver. So whenever there's a chance to run things in parallel, we will do that. We also detect things like where something in your build doesn't really have any effect on your final result, we can completely detect it and just remove it. For example, based on your configuration changes, some things are invalidated. Another part of performance is what happens when you repeatedly run the builder as part of your developer flow. One of the things that happens there is that even if you get things like build cache, what we still need to do is that as a first step, we make an archive all of your local files and send it to the daemon. And this becomes very time consuming when your source folder is growing. And for that, in Buildkit, we are now uploading this context incrementally. So when you're making changes in your source files, and press build, we only send out the changes. So it's almost constant time all the time. And of course, for performance, very important is the notion of build cache. We now have a very different model than what we used to have before. Before we compared JSON, try to figure out if one blob of JSON is similar to another blob. Now we can basically calculate the checksum for an arbitrary subset of your build definition, and that checksum is reliable. We can use it, for example, to automatically pull in your build cache from some remote storage like a registry. So that is, for example, very important for CI workflows, where at the moment you're probably are getting like a cache bust every time and need to rebuild everything from scratch. So in Buildkit, it can detect that this kind of definition matches for a certain checksum and ask for a registry, do you have something previous data that matches this checksum? Let's go back there. Some new capabilities I will mention is that, for example, now you can access the build results straight back on your client. So Buildkit is not only for building images, you can build anything with it. One thing we support now is called necessity invocation, but this means that you can have builds inside builds. You can generate your build definition as part of your build job itself. Hopefully I'll show this later. And one other thing is that we now automatically manage your storage. So, or like the storage that will be used for build cache. So you will not get this ever-growing list of images that you have at the moment. We will just keep it under this restriction that you can configure. And keep clicking too much. And one last really important design aspect of Buildkit is what we have listed here as extendability. So in the core of Buildkit, there's a new intermediate build definition format. And this is like it's very low level format designed for machines to read, machines to execute, machines to generate. It's not really something that you as a user would write. But if you run Buildkit, then everything runs on top of this intermediate format. So this is what will give you all those features. And in whatever way you end up in this intermediate format, you will automatically pick up all those new features and everything we supported previously as well, of course. So to get into this intermediate format, you would usually use something called like a component called a front end. And the job of front end is to take your some user format, something that's really very easy for users to read, write, and front end will take that format and convert it to LB. So one of the front ends we of course want to support is Dockerfile, but LB itself is not connected to Dockerfile in any way. You could build something really, really different in there. That doesn't have the Dockerfile layout or uses completely another model. It's also really good for testing out new experimental Dockerfile features. So now we can really add some new stuff into Dockerfile that used to be very hard. Like it's one of the hardest things is to get some new feature into Dockerfile, like seriously, like multi-stage builds took like 3 years or something like that. So, but in this way, a user can just target a specific version of a front end. We don't need to worry about that. If we add this feature, we break some users. We don't need to, and the user doesn't need to worry about that this feature will not get stable and maybe will be removed, or some other users don't have this, haven't updated yet to this feature. And on the other side, once the build is done, we have these components called exporters that allow you to take the build result and expose it in some other system. Of course, one we support is image. That's obvious that you will likely want to get an image back. Another one is that we support is just getting these files back in your client system. And of course, we can extend it in the future in whatever way the users would like. And let's see it in action. So, speaking of, so in here I'm in the source directory for Buildkit, and I have one Docker file in here. So this is already like, let's think it. So this is the Docker file that could be used for building Buildkit itself. It has already been prepared for multi-stage builds. As you see, there's lots of stages in here, and basically like there's a stage per binary, and something that you will probably see for like a complex Go application. And something that we would currently recommend you to do to get like really small image in the end. For example, like in the end, it's using an empty stage and copying all the binaries to there. So you only get the binaries in the final image. One of the problems at the moment is that even though, like, for example, this stage that installs runc, this stage that installs containerd, they don't have any shared dependencies. You still have to wait for this containerd, for this runc to finish before the containerd can start. And one other thing, for example, is that you can, in this file, you can actually choose what version of Buildkit you want to build, so what set of binaries. And even though you maybe don't want this set of binaries, you will still get them because they're just listed in this file. There's no way to skip them, or like for the builder to realize that this final stage doesn't actually have any dependency on it. So let's see if this is different now. Just clear the cache first. And to invoke it, to build this Docker file in Buildkit, you will use something called build control. That's like a control utility for it. And you will use the build command, and you will need to set what frontend you want to use. At the moment, the Docker file frontend that I'm using is behind this name. And there's two other options that you need to specify, especially for this Dockerfile frontend. So Dockerfile is a format that has this notion of a build context, and also like this concept that your build definition is in a file called Dockerfile. So you need to expose that you can share those local files with the daemon. And if I'm building it, you see that the output is very different from what we have at the moment. So there's already three stuff that have happened in parallel. What you see in white is currently being executed. What's blue has already finished. So it already pulled the images in parallel. It loaded the files to the daemon in parallel. And now it's building those three binaries. So two Buildkit binaries, one runc binary in parallel in here. And it should finish up soon. Last one to build in here, the daemon binary. And in the end, it finishes up by just copying them all together. So this is the final place where you would find them. Obviously, if I run it again, it's super fast. There's nothing to do here. One thing you might notice is that there was no pause even for sending those files. It's because we only sent out like 200K of my local files, while in the first transfer, I needed to send like 20 megs. So this is the incrementally sending only changes. So this 200K is the file metadata that we need to send just to do the comparison. So your modified files will be on top of that. And you can also see from this output that there's no containerd binaries in here because I'm building Buildkit in standalone mode at the moment, even though they were in the Docker file. And maybe let's look at what's happening with the build cache. So you can run this disk utility program, and this will just show you how much data is currently being used by build cache. We'll see that all of it is currently reclaimable because no other process is actually using this data at the moment. You can see where it came from. You can see how much it has been used. So this is all this data that the garbage collection can take into account when it hits your storage limits and needs to delete something. So these were some examples of features that you would just get by upgrading your current system to this new backend. But especially for this group, let's actually look at what's inside this LLB and how to use some LLB features that don't have an equivalent syntax in Dockerfile yet. So to just work on LB directly or to build something on top of it, one way to do it is that we provide this client library for LB. And it's a Go library that you can use in a chaining model to put together your build state. And a bit about the LB itself, it's actually a very simple format. It's just like a quantitative graph of vertices of operations, and there's only 3 operations that we currently support. So as you can see, it's a very different concept from a Docker file. And the first operation we support is this source operation. So this one you can use to get access to some remote data, for example, images, but you can also access like Git repositories directly. You can use the local method to access your local files. So execution operation is the one that actually runs your process in some defined environment, that anything that has happened before. And one new thing about it is that if you're working with LB directly, you can mount stuff from different stages to a certain path. So this data becomes available when this process actually runs. So this lets you just live mount data from other stages, for example, or from any other vertex without doing like an explicit data copy and losing space with that. And point of this client library is that you can pick any of those places in the chain and just call Marshall on it, and this will give you the binary LLB definition that you can send to the builder, and builder will figure out how to execute it. So let's see how that works. Let's try this one. So in here, I've just opened up the Go script. And what this Go script does is that it imports this package that I just showed. And actually, this script generates exactly the same output that the previous Docker file did. But now it uses like primitives from Go to actually put together this build definition. So in the main function, you see that I'm just calling the Buildkit function. Roughly every stage that you saw previously is converted to a function in here that returns one part of this state. For example, this is a function that returns an LB state that when executed will contain the final run C binary. And in the script, you can just flip around, for example, what version of run C you currently need. It will use the Git source directly to pull the data from GitHub, or you can set the version as local, then you can just use your local files in place there. And for example, this Go repo is probably too hard to follow at the moment, but what it essentially does is that it's a helper written in Go that will just live mount source directory into the right place in the Go path, so that if you run stuff through this function, just the source will basically magically appear in the right location in the Go path. And in the end, they're just again copied together. We don't have a copy operation at the moment, but no worries, because we can just define it in Go in here. So there's a copy function in here. It just uses the CP binary from Alpine image and just runs it directly in here. Just mounts the source path to one mount and the destination path to another mount. And the behavior is exactly the same, and the caching mechanism is exactly the same as in current Docker file. So let me build this one quickly. So I'm just building this script, and if I just run it, it will just print out this garbage definition, this binary definition that's unreadable. So, but if this time I will not use a front end, I will just directly pipe the definition to the builder. So this up differences you see is that basically instantly this Git source was copied from GitHub in here, and same way within other Git sources in here. And so we didn't need to wait for them to be cloned, and they were much faster. And actually the build cache is now much more, because now the root of the build cache is your git commit, not your arbitrary string that used to be in the previous one. And also we don't have those copy operations that we need to have in Dockerfile. We can just skip them, and overall it's just much faster this way. And of course, let's run it again as many times as we want. And just touch some file. So this would, if we made a modification in our current directory, this would mean that we need to rebuild I'm building it from GitHub at the moment. But this will essentially mean that the Buildkit part would be rebuilt, but not the other parts. Let's show this. So this time I'm building my local version. So it also lets you switch your local version directly with the GitHub version without modifying the definition at all, something that's not really possible at the moment with Docker files. So let's do local Buildkit source equals my current working directory. So this time you will see that some things were cached, Buildkit itself was not. So, and this is kind of the point I want to make, is that there's some optimizations that we can do just by having a smarter backend, but eventually to make those smart decisions, we need to get like really well-defined build definition. And the more complex build definition you can give us, the more smarter decisions we can give. And finish up with this point, I'm just going to show you something completely different, something that you definitely can't do at the moment with Docker files, and that's just directly building the Go binaries with Buildkit. So in here again, the point of this file is quite same as the previous ones. We are building the set of binaries that work together in the combination. But in here, I don't do any execution operations where I would run Go binary. Instead, I've imported this another helper library that I just built. And with this helper library, I just have this method build exe, and I just give like a Go package as an input, and I can set like build tags, like basically same inputs that your current Docker, when your current Go build binary would take. And what's happening here is that this file will generate an LLB that is something like this, that takes some of my local files, some of the files from Git, and then uses this a helper or a function library that I have built that was part of this import, and it runs this like a nested build operation with this logic that is built into this image in here. And in this graph, those nested build operations are behind this box in here, and you really can't see what's happening there because like while the builder is running, this block is actually generating a whole new graph, and this graph will have the same dependency graph that will be executed if you run your Go build locally. And before, I just took one of those boxes and I printed out what's inside this box actually, while it gets executed. And it's basically something like this. So let me just find something in here that I can show. So let's zoom in here. So basically, this is a graph where every node is building a separate package that's used in a binary, and it has dependencies for every source file and every package that this package imports. And in the end, you can see that it just links them together. And this is the final step for getting this binary out. So if you would be able to execute this one with Buildkit, first of all, we would have defined all our inputs really precisely, so that if we change some files that don't matter to Go at all, we never get any, we still get full cache always. And if we do change one of those files in this graph, it should only invalidate the cache for to all the parents of this single vertex, not everything around it. So let's see if we can try to build it. So this one has around 300 vertices total, and probably like 4,000 edges, something like this. So every vertex equals to a run command in Dockerfile roughly, and every edge equals to a copy command in Dockerfile. So probably not something that you would run with a Dockerfile. So let's build this script in here. So again, it's just a graph that's this graph in here, and just clear my cache so that we don't get any speed ups. And I'm going to build it, and I want to build my local directory. Source equals my local directory. So here, first things, it's pulling my image, and now it's actually it's pulling the Golang image that was dependency of my image, and now the actual subbuilds work behind. So everything that's white in here is currently being built. You can see the ticker on top. It's like it will run 300 containers. It has already run like 230. So you see that most of them are this compile commands. Some of them are link commands. And now it's finishing up. It's doing the final link, and now it's completed. So overall, we ran over 300 containers in here, and most of them compiles. There's even some C Go in here. So we, for example, run C has some C parts. We can pick this up as well and just install GCC on top of our image. So this was added here because C Go was being used. And of course, now when I run it again, it's instantaneous. So there's no changes in here. And if I update the file and run it again, it's still super fast. It only needed to run this step again. That took like 200 milliseconds in here. That basically just regenerated the graph again and verified that it was already cached. So it's quick. Let me just do a quick change. So actually change some file. So let's just add something in this variable. So what should happen now is that at least this package should be rebuilt, and well, the final link needs to happen again. Maybe it has some parent packages. So let's run it and see that it was still very, very fast. It just rebuilt this package in here. It did the link again, but these were really fast operations. So almost like accidentally, this might be like one of the fastest ways to just like securely do incremental Go builds. And yeah. So yeah, so this is one of the ways where one of the directions where this would go. So this was just an example for Go. You can of course define it for any language you want. You can define the build context in any way you want. So if you need some other libraries there that help your build, it's still capable. Will probably work very well for tests as well, because then if you're running tests, it will detect that some of your tests don't have the dependencies that have changed. So it can just skip those tests because you already ran them before. And probably even more important for like the integration tests, because with those other tools you can define your other like fixtures or some other binaries that needs to be in place while you're running the test, and you can use like regular Docker tools to do that. And that basically concludes my demo. Just wanted to mention that this is all in GitHub, all open for you to help out in. We have lots of issues still that we need to work on. One of the things to highlight in here is the remote workers case. Of course, like we want to be able to build in clusters to take full advantage of all your machines, not only build on a single machine, but of course just some random selection in here to check out. So yeah, thanks.
Any question? Going on. It's a big room. Oh, there's a mic right next to you.
All right, this is awesome. Congratulations. Yes, can you hear me? All right. So what is the purpose of having the SDK? I mean, I understand the core is fantastic. It has the multi-threading and being able to do everything at the same time, but why SDK and not, let's say, a domain-specific language? Yeah, YAML.
Which SDK?
What are you trying to achieve with the library?
With the library, I'm just trying to provide a way to make this graph more complex. So if you add more nodes to this graph, we can just make better decisions. For example, before when I showed that if you made one single modification in your working directory, we will just need to rebuild your local binaries because we don't know what the Go binary does. We can only assume that it uses this file in some way. But with the huge graph, every file is defined. If you change something that doesn't have an effect on the final binary, we know that and we can just skip it.
Great job. I can't stop. I see the similarities between this and Bazel, right? If this becomes Bazel implemented in Go, then is it gonna be like that?
Hard to say. There is some differences in here, and of course, yeah, there are similarities as well. Like technically, there's some differences of how we do caching and stuff. They're mostly different because we need to support things like Docker files. But yeah, we will see. Like, I would definitely just like if we could integrate Bazel into this, so that you just pick that you want to use Bazel as one of the components inside the build, and the Bazel logic will take over from there. But we will need to figure out if that's possible or not.
Any other questions? Round of applause, please. Thank you.